All right, guys, here we are. This is first attempt at a online lecture, so see how it goes. Um, First of all, I will post a series of shorter videos rather than one longer video. They should be up by Monday and Wednesday with particular content for those days. And you also um, will have a quiz just to kind of check in with you to make sure you're actually viewing the content. Um, and you're welcome to ask me questions about understanding of the content. The quiz, the reading quizzes and the viewing quizzes, at least, you should be able to do without asking me any questions. But feel free to reach out by email. I'll also have regular Zoom hours. That is virtual office hours where you're welcome to jump on a Zoom call and ask me questions. So now that's taken care of. Let's start with content. Before spring break, a long time ago, we were in the middle of section 5.7, where we were talking about inverse trigonometric functions. Just as a reminder, inverse functions are functions that essentially undo each other. So when you see, for example, this -1 over one of the trigonometric functions, that indicates that it's an inverse. We discussed a couple of different ways to evaluate inverse functions. And then we moved to composite functions. So we are composing an inverse function, a function with its inverse, I should say. We worked through 3 of these problems last time. And we noted that if the input value, so the input value, falls within a certain interval, then we can utilize this list. The interval has to do with what we restricted the domain of the inverse functions to be, or the domain of the functions to be, in order to find the inverse, I should say. So for example, if I am asked what is the sine inverse of the sine of pi over 6, I could note up here that pi over 6 is, well, it's in the given interval negative pi over 2 to pi over 2. And because that is the case, I can note that the sine inverse of sine pi over 6 is just equal to this input, pi over 6. There are 2 others for which this is the case. One of them is D, tangent inverse of the tangent of 0. That falls in this category. You might note that 0 is in the interval negative pi over 2 to pi over 2. Therefore, since that is the case, tangent inverse of tangent of 0 is just equal to the input 0. And very similarly, if I look at E, the cosine of cosine inverse of 0.7, I can note that, a little bit of room up here, I can note that the cosine of the cosine inverse of 0.7, well, 0.7 is in the interval -1 to 1. Falls between those 2 numbers. So this has a value of just whatever the input is, that's 0.7. All right, so we have those 3 taken care of. But you might notice that B and C are different. You might notice that 5 pi over 6 is not in the interval that we referred to above, this negative pi over 2 to pi over 2 interval. So it's not in negative pi over 2 to pi over 2. So I can't use the above list to evaluate it. And very similarly, negative 2 pi over 3 is not in the interval for which it must be to evaluate cosine composed with its inverse. So that's right here, the interval 0 to pi. So it's not in that interval 0 to pi, certainly, because it's a negative number. So because of that, we have to establish a different way to evaluate these, because that angle, in this case 5 pi over 6, is not in the range of sine inverse, and this angle negative 2 pi over 3 is not in the range of cosine inverse. So let's talk about that now. And I'm going to go to the whiteboard because that makes it a little bit easier to work through these problems. All right, let's do this. First of all, let's evaluate the sine inverse of the sine of 5 pi over 6. Okay, so I can't use the list. I'm going to work from the inside out. I'm going to start by evaluating this portion of the expression. Okay, so I'm going to pull out my unit circle, and I'm going to say, well, I know from that the sine of 5 pi over 6, I'm not using inverses for this part, so there are no restrictions. 5 pi over 6 is found here on my unit circle, and I notice that the y value at that point is 1/2. So I have evaluated this inside portion of the composition. Now that I've got that, I can replace sine of 5 pi over 6 with 1/2 and continue to evaluate. So this means that the sine inverse of the sine of 5 pi over 6, well, that's equal to the sine inverse of sine of 5 pi over 6, which we just established is 1/2. Okay, I've got that. Oops, let's make that black. And I know how to evaluate this. Sine inverse of 1/2, well, I'm looking for a y value on my unit circle in either quadrant 1 here or quadrant 4 here. It's positive, it's probably in this quadrant. So I am going to find that y value. Looks like it occurs right here. Looks like that's an angle of pi over 6. So sine inverse of 1/2 is pi over 6. So we work that step by step. That means that whole expression, sine inverse of the sine of 5 pi over 6, has a value of pi over 6. So just to recap, I started with the inside portion of this expression because this interval 5 pi over 6 was not between negative pi over 2 and pi over 2. Once I evaluated that, I could replace sine of 5 pi over 6, that inside portion, with what I know it's equal to, and then use my unit circle to again evaluate. And I see that I get an output that is certainly between negative pi over 2 and pi over 2, or in these two quadrants. Let's work the next one. Okay, I'm trying to find the value of cosine inverse of the cosine of negative 2 pi over 3. Okay, and I'm going to do it the same way I did before. I'm going to work this inside portion first because this angle here is, as we stated, it's not in the interval 0 to pi. So it's not a valid output for cosine inverse. Okay, so cosine of negative 2 pi over 3. Well, I could find the angle on my unit circle, or I could remember that because cosine is even. Cosine is even. This is the same as the cosine. of 2 pi over 3, which if I look on my unit circle, see that that is equal to -1/2. That angle is found here on the unit circle. X value at that angle is -1/2. Okay, so I've got that portion. I can do what I did before, and I can replace cosine -2 pi over 3 with that. Let's do that. So cosine inverse of the cosine of -2 pi over 3 is equal to the cosine inverse of what I know cosine of -2 pi over 3 is equal to. We said it's 1/2. Excuse me. Now to finish up, I can look on my unit circle and find some angle in the range of cosine inverse, which I know is in the first and second quadrants from 0 to pi. I'm going to find some angle for which the x value is 1/2. It's going to be in the first quadrant. It's going to be right here. It's an angle of, nope, sorry. I have a negative sign here. So I need to input that here. There we go. So I'm going to find some angle for which the x value is a -1/2. So that's over here. That's an angle of 2 pi over 3. So this means that the cosine inverse of the cosine of -2 pi over 3 is equal to 2 pi over 3. And that finishes that problem.